Welcome to the deep dive. Today we're getting into something really critical, a growing issue in kids' eye health, high myopia.
Yeah, we're talking about nearsightedness that gets so severe it actually stretches the eyeball. And look, this isn't just about needing thicker glasses. It seriously increases the risk for things like glaucoma, retinal detachment, conditions that can cause real sight loss. But it often starts in childhood, and if we catch it early, we can often prevent the worst outcomes.
That's exactly right. The challenge is that the best time to intervene is usually when a child is quite young, under 10, while the eye's still growing significantly. And the gold standard, the key measurement we rely on to track this growth, is axial length, AL, basically how long the eyeball is front to back. Longer AL generally means higher risk. And clinicians, well, they use benchmarks like the Tideman percentile curves from 2017 to see if a child's AL growth is faster than expected. To flag those who really need treatment fast. Early intervention is absolutely key here. It really is. So our mission today, we're going to unpack a recent study. It compares a new piece of tech, this device called MYAH, with two established players, the Pentacam AXL and the IOLMaster 700. The big question is, can we rely on this new tool for the super precise measurements needed to monitor kids with myopia?
And it's a fair question because you need to understand that these devices don't all work the same way. They all measure axial length, yes, but they use different underlying physics, different kinds of light technology to get that measurement.
Okay, so it's not just comparing three rulers, it's like comparing different types of rulers.
Yeah.
Let's break down those differences.
Exactly. It's sort of a tech showdown. So first up, the new one, the MYAH. It's actually designed with myopia management in mind. It's compact, and it even has those Tideman curves built right in, which is handy. It uses something called optical low coherence interferometry, OLCI.
OLCI.
Yeah. Then there's the IOLMaster 700. This is a bit of a workhorse, often used for planning surgeries like cataract surgery, but it's excellent for measurements too. It uses swept swords optical coherence tomography, or SSOCT. Think faster, higher resolution scanning, measuring right along the line of sight.
SSOCT. Okay. And the third one?
The Pentacam AXL. This one's interesting because it's a bit of a hybrid. It uses a Scheimpflug camera for the front of the eye, but for the axial length itself, it uses partial coherence interferometry PCI. So you've got OLCI, SSOCT, and PCI. Three quite different approaches, all aiming for the same number.
And the reason we, and more importantly, clinicians and parents need to care about these differences comes down to consistency, doesn't it? If a child gets measured on an MYAH at one clinic, then moves, and the new clinic uses an IOLMaster, can you trust that the measurements are comparable? We're talking tiny changes here. 1/10 of a millimeter difference over a year is huge in a growing eye.
Precisely. Interchangeability is crucial. If the devices don't give you the same reading, or at least incredibly close readings, then you lose that continuity of care. You might think progression has suddenly sped up or starved when it's really just the machine difference. That could mean unnecessary treatment, or worse, missing a critical window for intervention.
Okay, so let's dive into the results. The study had 60 myopic kids, average age around 10. Let's hit the most important finding first, axial length. What did they find when comparing these three devices on AL?
Well, the news here was actually very good, quite reassuring considering how different the technologies are. They found no statistically significant difference in the axial length measurements between the three devices. The p-value was 0.06.
0.06, so right on the edge of statistical significance, but clinically suggesting they perform very similarly.
Exactly, and when you look at the actual numbers, it really brings it home. The average AL measurements were almost identical. Pentacam AXL, 23.61 millimeters, IOLMaster 700. 23.62 millimeters, and the new MYAH, 23.61 millimeters.
Wow. Okay, so the biggest difference between any two is just 0.01 millimeters. That's 10 micrometers. That feels incredibly precise for different methods. Why is that level of agreement so much more critical for kids compared to, say, an adult needing cataract surgery?
Right. It's about the tracking. For an adult getting a cataract operation, you usually measure the eye once to pick the right lens implant power. But for a child with progressing myopia, you're measuring them maybe every 6 months for several years. You're looking for growth that might only be 0.2 or 0.3 millimeters a year.
Oh, okay.
So if your machines have a baseline disagreement of, say, 0.1 millimeters right from the start, that error could obscure almost half the real progression you're trying to detect. It messes up the trend analysis.
That makes sense.
And that's why the other statistic they looked at, the intraclass correlation coefficient, or ICC, is so important here. For axial length, the ICC was 0.99 0.999.
0.999. Translate that for us. What does that incredibly high number mean practically?
It basically means you can have very high confidence that these three devices are measuring the same thing in almost the same way regarding axial length. So if a child starts on a Pentacam, then moves and gets measured on a MYAH, you can trust that the AL number is comparable. The technology itself isn't introducing significant noise into that key measurement. It confirms these devices can likely be used interchangeably for AL, which supports findings from other similar studies too.
That's a huge relief for managing myopia consistently. Okay, so AL looks solid, but the study went further, didn't it? It looked at other things like the curvature of the cornea keratometry or K values and the width of the cornea, the corneal diameter. What happened there?
Ah, yes. And this is where things get a bit more nuanced. Unlike the axial length, for the keratometry measurements, that's steep K, flat K, and the average K, the study did find a statistically significant difference between the devices. The p-value was 0.00. So statistically speaking, they don't give the same K readings.
Why would they agree so well on the total length but disagree on the front curve?
Well, it likely comes down to how each device measures that specific part. Remember, AL uses light going deep into the eye. Keratometry relies on analyzing light reflecting off the very front surface, the cornea. And they use slightly different techniques for that. The MYAH and Pentacam use corneal topography mapping, while the IOLMaster uses reflections from specific points.
Okay, different methods, different results.
Yeah.
But you said nuanced.
Yes, because here's the crucial part. Although the difference was statistically significant, the researchers argued it wasn't clinically significant, at least not for this purpose. The actual size of the difference was very small. The maximum average difference in K values was only about 0.15 diopters.
0.15 diopters.
Yeah.
Okay, why is that difference statistically real but maybe clinically okay?
It's all about the application. If you were using these K values to calculate the power of an artificial lens for cataract surgery, like an IOL, even a small difference matters a lot. A 1 diopter error in K can throw off the needed IOL power by maybe 1.4 diopters, which affects the surgical outcome. Big deal there.
Yes.
But for tracking myopia progression in kids, you're mainly watching the change over time. The absolute K value isn't quite as critical as the AL trend. Since this 0.15D difference is pretty small, just barely over what some consider a threshold for clinical notice, around 0.14D, the conclusion was it probably wouldn't mess up the follow-up or management decisions for myopia progression. The agreement, the ICC for K, was still very high at 0.989.
Okay, that makes sense. The goal is different tracking change versus precise surgical calculation. Good distinction. Now, what about the corneal diameter, the CD? Same story there. Statistical difference, but maybe okay clinically.
Pretty much, yes. They found statistically significant differences in the mean horizontal corneal diameter as well. Again, p equals 0.00.
And how big was the difference this time?
The largest average difference was between the Pentacam AXL and the IOLMaster 700, about minus 0.21 millimeters. So the Pentacam measured slightly wider on average.
Any idea why they disagree on the width?
Again, it probably comes down to the detection method. To measure diameter, the machine has to find the limbus, that's the edge, where the clear cornea meets the white sclera. The IOLMaster uses specific LEDs to pinpoint this edge, while the Pentacam and MYAH use their topography systems. Different ways of defining that edge can lead to slightly different measurements.
But still clinically acceptable for tracking.
That was the conclusion. Despite the statistical difference, the overall agreement for CD was still considered strong, with an ICC of 0.900. So, reliable enough for the intended purpose of myopia management follow-up.
Okay, let's pull this all together then. Thinking about this new device, the MYAH, and its place in clinics, what's the bottom line?
The main takeaway is quite positive for the MYAH. It performed reliably. It showed a high degree of agreement with these two well-established instruments, the Pentacam AXL and the IOLMaster 700, across all the important parameters they measured.
So for you, the clinician or the parent listening, what this suggests is that the MYAH looks like a solid, trustworthy tool. It can be reliably used for that early diagnosis and then for monitoring the progression. And having those Tiedemann curves built in might simplify things a bit in a busy clinic, less manual plotting.
Definitely useful features, but, we should also pump the brakes just a little and mention the study's limitations. It's important context. This was retrospective, looking back at existing data.
Right.
And the sample size, while decent, was 60 children, specifically 60 eyes. Not enormous.
And crucially, it was just one measurement in time for each child. Right. For a device meant to track growth over years, that seems like the biggest asterisk.
Yeah.
How do we know if today's reliability holds up over the long term?
That is the million-dollar question, isn't it? They confirmed excellent agreement at a single point, but they couldn't assess how well it measures the change over 6 months or a year or 5 years. That requires a prospective study following kids over time. They also didn't include kids with really complex degenerative myopia. So yes, the next step is definitely seeing how it performs in tracking actual progression longitudinally.
Still, focusing on that key parameter, axial length, the fact that they found such incredibly strong agreement there across all three machines is really the headline, isn't it? It suggests a high consistent standard of care is achievable for AL measurement, regardless of which of these specific instruments is used. That's got to be reassuring.
It absolutely is. Consistency in AL is fundamental. But it does leave us with a thought to chew on, doesn't it? Since the study focused on point-in-time reliability, and a big feature of the MYAH is those built-in percentile curves for predicting risk, what challenges remain improving the long-term efficacy of those predictive features? Being accurate today is one thing. Reliably forecasting where that child's eye growth is headed based on its integrated software, that's the next hurdle. Can you truly trust the trajectory it plots over years? That's what future studies will need to nail down.